Bismillahirrahmanirrahim. Let's start integration of P1. Um, when we are up to the integration, just remember that this integration is totally the reverse process of the differentiation. Okay? So you need to be really good at your differentiation if you want to learn this integration efficiently. So you have learned the first technique of differentiation, that is the derivative of x raised to power n is n x raised to power n minus 1. Now you see that if you have to get back this x raised to power n, so it means if this is n x raised to power n minus 1, then you need to add a plus 1 here. You need to add a plus 1 here, and you need to divide this with n so that you get that x raised to power n back. Can you see that? So if I just write this n minus 1 plus 1 over here, so that would help me to tell you that what is the first technique for the integration. So if you have to, this is the sign for the integration. If you have to integrate x raised to power n with respect to x, so this will be x raised to power n plus 1 over n plus 1. And then you write a plus c with this. I'll tell you why do you have to write this plus c with that, okay? So guys, look at this. This is your power at the moment. So you add 1 into it, and then you add 1 into it. So what happens? You get your x raised to power n back. So this integration, a reverse process of differentiation. So now you just forget this differentiation and now focus on this integration. Now, as again, I was just telling you that forget this differentiation, but the thing is that your first technique that dealt with the algebraic expressions, like if you have x cubed plus 5x squared plus 3 over x plus under root x plus maybe 3 over 2 x raised to power 5 over 9 plus 6. So you see that all these terms, they could have a plus or minus between them. And if there was something like this, suppose you had x cube over x and there was x under root x. So you had to multiply them, you had to simplify them before you could apply this first technique onto uh, just to differentiate this. So the same would happen here in this first technique of integration. So let's start with the very small, like just one term expressions. For example, you have to integrate x cube. Okay, the integral of x cube would be x raised to power 4 over 4 plus c. Just keep on seeing this, keep on recording in your mind that what's happening here. Suppose you have uh, 2x squared dx. So this is going to be 2x cube over 3 plus c. Suppose you have to integrate um, let's say under root x, okay? So don't worry about this under root. This actually means x to the power. Yes, beta?
सर सर जब हम इसको नीचे से करेंगे ओवर 3 तो हम मल्टीप्लाई नहीं करेंगे
With what?
सर उसकी पावर से पहले
No, 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 no. It's not that thing over here. We don't do that like 2 into this. This is done in your differentiation, not here, okay? Not here. You just divide it. You actually divide it with 1 plus that power as I'm doing here. This is 3 over here. So, you know, everything is totally opposite here. Okay? So, this is x raised to power half plus 1 over half plus 1 plus c. So this is x raised to power 3 over 2. You have here 3 over 2 plus c. And you can finally write it as 2 over 3 x raised to power 3 over 2 plus c. Just keep on seeing this. I'm just, first of all, I'll try to make you people used to the single term expressions, okay? Now suppose you have to integrate just 2, okay? So imagine if it is 2, you can imagine there is x is plus 0 with this, okay? So when you apply that plus 1 with this and then 0 plus 1 with this, so this would become 2x. So the integral of 2 dx would be 2x plus c. And in your notes, you can write that if you have a constant k and you want to integrate this with respect to anything, so that would become kx. Guys, if you remember, if you recall your differentiation, that when you have to differentiate a constant, for example, when you have to differentiate this 2, so this resulted into a 0. Okay, but here this is becoming kx. So in a way, your expression goes one power up when you are integrating, and here it goes one power down when you differentiate. For example, if you recall that the derivative of x square, so that was 2x, and now when you integrate this x square here, so this will be x cube over 3 plus c. So this is going one step up. Okay, now let's go on to integrate two-term expressions. Now suppose you have to integrate x squared plus x, and that is dx. So this integration is distributed inside the way it was happening in the differentiation. So the integral of x squared would be x cubed over 3, and the integral of x is going to be x squared over 2 and then plus c. Okay, now suppose you have to integrate um, x raised to power 3 over 2 minus uh, 5 over x squared. Okay, so first of all, you will be writing it as x raised to power 3 over 2 minus 5x to the power minus 2. You see, I haven't removed these integral signs and this dx because I have not integrated it yet. I am trying to write this in a form that I can easily integrate. Now I can integrate this because this has been written into the form x raised to power n. Okay, just one term. And it is in the numerator. Okay, so now this is going to be x raised to power. Now you must do that mentally, that what is 3 over 2 plus 1? Hmm? So that is 5 over 2. So rather than wasting your time over here, so 3 over 2 plus 1 is going to be 5 over 2. And you know that you have to write over 5 over 2. So anything over 5 over 2 becomes 2 over 5 into whatever you have here. Okay. So let me write 2 over 5 here. Now don't blame me that I'm going too fast, because I know you people have done your O levels and you know that what is 1 over 5 over 2. So that is 2 over 5. Okay. So try to become a smart mathematician, okay, by skipping such steps. Okay. Now this is going to be minus 5, and this is x is to power minus 1 over minus 1 and then plus c. Okay. This is cancelled with this. So you have 2 over 5 x is for 5 over 2 plus 5 over x plus c. Now time to tell you that why do we have to write this plus c. Okay, guys, see, do you remember when you had y equal to x squared plus 5x plus 2? And when you were differentiating this, you were having 2x plus 5. And this 2 was eliminated. This was murdered while you were differentiating this. So when you integrate it, you must get it back. Okay. So when you integrate this 2x plus 5, 2x plus 5, guys, see, you get 2x square over 2 plus 5x, and then you write a plus c, that if there was a constant that was killed, that was eliminated, that became 0 during that hurricane of differentiation, then this is the atma of that constant. Okay, and later, maybe in 2 or 3 days, you will learn how to get this c actually back. Okay, so this becomes x squared plus 5x plus c. And that is why we call this the indefinite integrals. Okay, when you are not clear that what is the c, So we call them indefinite integrals. Okay? Acha. So, um, then once you have done this two term expression, then I can tell you that this is something a bitter um, thing that I want you to swallow this. Guys, when you have dy by dx, and that is equal to 2x plus 5. Just see this, we'll come back to this later. So what you people do is you write it as 2 dy, that is 2x plus 5 dx. You cross multiply. Now this side is integrated with respect to y, and this side is integrated with respect to x. So imagine if there was a 1 over here, like if you have 2 dx, so the integral is 2x plus c. And if you have 2 dy, this would be 2y. Okay. And if you have just dy, so that would be y. Because you can imagine there is a 1 over here. Okay. So 1's integral would be y with respect to this y. So this becomes y over here. And this is going to be 2x square over 2 plus 5x plus c. Now you must mind here one thing, that I didn't write a plus c with this y. Hmm? Why did I write a plus c with the y? Hmm? Because an equation can have only one constant in it, like this 2 is one constant, so there is no need to write constants on both the sides. Okay, so you just forget whatever you have seen over here. You just assumed you were in a dream. Okay, we'll get back onto this maybe 2 3 days later, inshallah. Okay, so guys, let me take you to the book and we practice the questions from there. So here we are. So when you have to integrate this, I would suggest you change this question with, I don't want you people to be confused with more than one thing. So you just imagine that you have to find integral of 15x. Just change into this. So the integral of 15x square would be 15x cubed over 3 plus c. Okay, and this is going to be 5x cubed plus c. Look at this question. Okay, let's change into this. Okay, so now this would be half. Okay, this half can be written inside or outside, that doesn't matter. We need to move this x cube up here. So I am not integrating, guys, this at the moment. I'm just writing this in the form that I can integrate. Okay, so this is, now I can integrate this. This is half x raised, just a minute, minus 2.
Sir?
Yeah, just a minute, beta, just 1 minute, over minus 2 and then plus c. So you have minus 1 over 4x square. Yeah, beta, please tell me what is your problem. Yeah. Mhm.
सर मैं कंफ्यूज हो गई हूँ, सच आपने क्वेश्चन में ए उसका पार्ट किया है, तो आपने
Mhm.
5x क्यूब प्लस सी क्यों लिखा है?
Because 3
ओ
5s
अच्छा
are
सर,
15.
एक और चीज नहीं सर, आपने प्लस सी क्यों लिखा है?
I have told you, you have to write a plus C. I have been writing this right from the beginning of the class. Let me show you. Let me give you the proof here. Look at all these integrals. I have written this plus C everywhere. Everywhere you have to write this PC. Maybe you're late, or like you haven't had the cup of tea in the morning, so that's why you just missed that, Hannah. Hmm? So, beta, that is a rule. You have to remember that whenever you integrate, you have to write a plus C. And I use the word Atma for this, that this is used for that constant that was eliminated while you were differentiating. Okay? Remember, integration only takes place once you have differentiated something. So when you have to go back to that original thing, so you have to write that plus C. Okay, guys. Now, um, so I think uh, I should make you used to this notation here. Okay, now let's follow these steps here. that, let me cover all this area here. So, whenever you have a dy by dx, remember when you were differentiating, bacho, what was happening there? Remember, you were told that if you have y equal to blah 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 blah, so you will have dy by dx equal to this. And then you were told that if you have f of x equal to blah blah blah, and when you differentiate this, this would become f dash of x equal to this. Do you remember this? Hello? Do you remember this? That y is
Yes, sir.
changed into dy by dx and f of x is changed into f dash of x. Okay? So, bacho, now for this, when you have been given dy by dx, please follow all these steps. You will have to copy down the things. Okay? I'm going to do that again. So, this is dy by dx that is equal to 15x squared. So, you will cross multiply. This is 15x squared dx. This side is integrated with respect to y. This side is integrated with respect to x. So this is y is equal to 15x cubed over 3 plus c. And finally, you can write it as 5x cubed plus c. Look at this f part, okay? Please copy them down. Now this is dy by dx, that is 4 over under root x. So one side has the dy, the other side would have the dx, okay? So I moved this under root x to the numerator and then I cross multiplied this as well. So this side is going to be integrated with respect to y, this side is going to be integrated with respect to x. So when you integrate this dy, this becomes y, and this is 4x raised to power. What is minus half plus 1? Hmm?
Half.
Yeah,
Half
so you
minus.
must know that this is half and you have a half here, okay? And then this becomes 8 under root x plus c. It's 8 under root x plus c, okay? Let me take you to the next question then. Now, when you have f dash of x, look what will you be doing here. When you have f dash of x, so guys, look, this would be uh, now you have, let's say, let's do this d part, okay? This is question number two's d part. So you have f dash of x that is equal to, let me be clever here, let me write it as 9x raised to the power minus 7 minus 3x raised to the power minus 2 and then minus 4. Okay, now girls, you can simply write here dx with this. You can simply write here this dx with this. Okay, so when you integrate f dash of x with respect to x, this would become f of x. Okay, and this becomes 9x raised to the power minus 6 over minus 6. Remember, we are adding 1 into it and dividing that power with that power as well that we get after adding 1 into it, because the rule that we're following, that is x raised to the power n's integral, is x raised to the power n plus 1 over n plus 1 plus c. Okay, this would become minus 3 x raised to the power minus 1 over minus 1, and this minus 4x, and never forget to write this plus c, because you're dealing with the indefinite integrals. Okay, now a bit of simplification here. 3 2s are 3 3s are, so this f of x is minus 3 by 2 x raised to the power 6 plus 3 over x minus 4x plus c. Okay, let me give you some time to practice these questions, okay? And then you just play with these parts of the first two questions, and then I'll take you to the third question.